Hey, so you have to accommodate for all the states of the world, which, if there's two bonds, then what does the sample space actually contain? If you have, they're totally independent in how they behave. So you have bond A can either survive or default, and then you have bond B can either survive or default. So what are all the states of the world? You could have A survive and B survive, or you can have A default and B default, or you can have A survive and B default, or you can have A default and B survive. Those are pretty much that's the entirety of the sample space. So the probability of one of these things happening is 1 because these are all the things that can happen. What are the probabilities of each of them happening? Well, that's what you already started to calculate up here. You said the probability of both defaulting, which is this one here, has a probability of 0.0016, and you said the probability of both surviving is 0.9216. So the probability left over, which is that one survives and one defaults, although I'm not specifying which survives and which defaults, the sum of those two probabilities must be 1 minus these two probabilities. So 1 minus 0.9216 minus 0.0016. Whatever that is, that's going to be like, I don't know, about 8%, say. Oh, you have it there. It's over here. 0.0768. That is the rest of the sample space. And that's the probability of one of them defaulting and one of them surviving.